All right, we are live. Let me go. I put the test in there. I'm going to take some questions in a minute. I want to go here and grab a copy so that the people online can also view, because they didn't get their test back. While I'm here, do you guys see this, the old tests? This is where I keep them for years and years and years. You can go back there and use them for practice. And I put this one in there. I'll just bring this one up here. Did any of you study last year's test or last semester's test for this, or just? Okay, it wasn't much different. All right, I'll leave that up there for anybody online that might have any questions. Are there any questions about the exam? Any problems that you would like me to do? Things that I know you guys should have some questions because overall the class average was not so good.
We retake the test.
Well, you can do better if you do better on the final exam. Do you remember that part in the syllabus that says that you can improve your test scores?
Yeah, I had one over it.
Yeah, go ahead and look on that, because you can replace the exam completely if you do better, obviously, if you do better on it. So in a way, you do get a second chance. Any questions on any of these things? I mean, I'd be amazed if nobody had. That's why I'm kind of scrolling through it to see if anything sparks your imagination.
I have a question.
Go ahead.
Page 3, question E.
Question E. Where you at? There it is. Yeah, when I grabbed these problems, I went through your homework and just picked them out of there. So I thought this was, well, it was a homework problem, but the responses were not real good on it. This thing here, you probably get better mileage if you think of it as being a proportion. I'm gonna go write something over here first. You guys remember what this is called when I multiply that part to that? This part. What do they call that? Cross multiplication. Obviously cross multiply. So over here, if you think of this as 3x plus 5 over 5 equals -2, 1, then you can see it looks similar to the cross multiply thing. So now what I'll do is this. I'll take this here times this here. Then I'll take this here times that there. So I made a little cross markings. Now, when I do 3x plus 5 times 1, I'll have 1 times x plus 5. The other side will be negative 2 times 5. That's the cross multiplication. Now multiply out both sides. The left side is really simple because that 1 doesn't do anything. So you get 3x plus 5 equals negative 10. Now at this stage, it's a standard problem. Here, the next step, it's the standard things from here on out. Subtract 5. And you get 3x equals negative 15. Then if you want to get x by itself, what do you do now? Divide by 3. There's more than one way to do this one, but that seemed like the most obvious way. Other questions as we scan through the test? If you guys need me to scroll through the test problems, let me know. Where was that at? In here? I'll go back to it. If you didn't get it all, I'll get there. But I just want to see if anybody has any questions in here. But this one, people did well on number 6. For those of you that are always online, if you just write me an email, I'll scan your test in and send it to you via email. Anybody in here? You guys are permitted to speak. All right. Do I do the old going once, going twice?
Can we do H, Professor, on page 3?
Yes, H. That one there? Yes.
Thank you.
Look at number H. What would you think of if you're looking at that? What should you be thinking of doing very first thing? What do you think would be the very first thing you'd want to do for something like this? All right, let's try another tactic. It looks like a bad equation. What makes it so bad? The fractions. So the first thing you'd want to do is wipe out the fractions. How would you wipe out the fractions? Well, right now we've got a 3 and a 5. So there's 2 different denominators. So you need to take the LCD, which is going to be what, 15? Like so, multiply everything by that LCD. But when you do it to some things, put it over 1 so it makes the multiplication easier. But this last one, I believe, is just 15. I'm going to leave it just as 15 there because, well, that 7 didn't have a denominator, so I don't think I need to cancel anything. All right, so as I go across here, this 3 will go into that 5 times, leaving you with 20x. No fraction.
Question, how did you get, oh, you multiplied 5 times before?
Sorry.
Okay.
Now the 3 goes into the 5 times. 5 times 2 is 10. On the other side, 5 goes into the 15 3 times. We get negative 9x. And then 7 times 15 is 105. From here on out, it's pretty standard. I'm going to get x's on one side of the equation, so I'll add 9x to both sides. Add 10 to both sides. $29x equals 115. Last step is to divide by 29. It does not simplify. 29 does not go into 115. So we get 115 over 29 for our final answer.
Thank you.
Sure. Other questions?
I have one.
Yeah, go ahead.
Page 4. Question 9.
Question 9,
Yes, sir.
page 4, question 9. It's about as big as I'm gonna make it anyways. All right, here we have, this is one of these problems where you're trying to find the, what do you call it? The best price or the best unit price for a collection or for things that you buy. So what they have is, suppose you go to the store and you're trying to buy coffee. You see a small bag for $3.19. You see a large bag for $7.98. This is a common scenario, isn't it? Which bag is the better buy, the little one or the big one? And you hate to buy the little one if it amounted to paying a huge amount for that small quantity. So how do you determine what you pay, what the unit price is? What is the unit price here? The quantity they're talking about is the ounce. You always put the dollars on top. So for this one, the 11.51,
Goes with this, the unit cost equals the price divided by the quantity. And in this problem, since you're talking about dollars and ounces, all of your answers will be in the format of dollars per ounce. So start with the first one. We got $3.19 for 11.5 ounces. Just use your calculator, get a few decimal places. You don't need a lot. If in the grocery store, I'm pretty certain that they go to 3 decimal places of accuracy. But you'd have to check me on that. I'm not sure. So all you do is do 3.19 divided by 11.5. I'm gonna go with I'm gonna go 4 decimal places, just because. Extra careful. Here's what I get. The number my calculator gives me is 0.2774. I've stopped there because I've. Now, that number means nothing in and of itself. You do need to know that this is that much money per ounce. So it amounts to a little bit less than 28 cents per ounce. Do the same thing with the other one. The other amount was $7.98. And it was 30.6 ounces. Because it's not exact. Now take your 7.98 and divide it by the 30.6. And to 4 decimal places, I get 0.2608. Per ounce. Which is cheaper of these two? The bigger bag is because it's a little more than 26 cents an ounce, isn't it? Whereas the other one is closer to 28 cents. So this is the better deal. So the 30.6 ounce is the better buy. Okay. That's because this number is lower than that. Other questions? That's right.
So somebody sold a certain amount of like, but you can I see another person.
Oh, yeah. Let's see, this is the one. Number 4. Let's see, Don Aldo and Carlos served a total of 132 orders on Monday. So this line right there tells me something. This is D plus A C. Pause there and do what I'm doing right now. Now, let's start doing some other things here. Aldo served 7 more orders than Donna. So we know that Aldo equals Donna plus 7. Is that true? Carlos serve 3 times as many orders as Donna. So we know that Carlos equals 3 times Donna, don't we? So good. Now let's look at that original equation I had. I had D plus A plus C was 132. Now what I'm going to do is to see where I have changed the A into a D plus 7 and the C into a 3D. I'll pause there while you absorb that one. See where I made the substitutions here? This A, C, what is so great about this sort of kind of substitution? What makes it so great that I just did that?
Like terms.
Exactly. Well, look, everything's a like term practically, isn't it?
Right.
More importantly is we have one unknown quantity, which is D. Everything has D in it now. So I can combine my like terms, that's 5D plus 7. That's equal to 132. Of course, from here on out, it's the normal stuff. Subtract 7 and then divide by 5. So that's 5D equals 125. And then if you want to get D all by itself, divide by 5. D equals 5. Of course, that's not the answer, it's the problem. They asked me how many did each of all of these guys serve, and I not only know what Donna served. Donna served 4 these burgers, or what are those things? So we now know that Donna served 25. Each of these had a thing, like the A was equal to D plus 7. So can you tell me what A is going to equal?
2.
Similarly, C was equal to 3 times D. So can you tell me what C is equal to?
7.
Again? No. It's D. D is 25. 25. 3 times 25. 75.
25.
So then we got them all. We got Carlos. Served. $75. Well, Carlos was busy. And then who was the last guy? Hello? Here's another question unrelated to the problem at hand. Who do you think earned the best tips that night? Probably Carlos. Unless he was crashing everything as he was doing it, but whatever. Go ahead.
Where did the 5 originally come?
Which 5?
First time to the first 5 he's also in there.
Right here, the 5 equals 7.
Scroll up, Storm.
Those guys right there.
I got the first part, but when you put the 5D, but like where did you get that 5? Where did it come from?
You have 1D plus 1D plus 3 Ds. How many Ds are there?
Oh, okay, I see what you did.
So yeah, we're just collecting like terms. Other questions on this test? The first test is juicy.
All right, I'll try this again. Going once, twice, three. All right. See again? The whole front page? Was that hard? Let me see. Oh. It's Acrobat. No, I don't want to do that right now. Oh, these things. Let's take a look here. That's a good question. Let's see here. How hard are these to do? Wait, I gotta, let's see if, can you do these just using the calculator and not even using any kind of ability whatsoever? So let's see if this works here. All right, so I want to do part A, just using this machine and touching nothing else. Not saying that you did that, but I just am interested. I've never tried it. This isn't a scientific one, is it? We need this scientific calculator. All right, let's see if I can get it. 4 times 7. Oh, look up there. See, oh, it's not doing it for me though, is it? Then I've got to do plus 6 divided by 2 minus 7, 24. Let's see what happens. I just did them as they came. You didn't, is that the right answer? Okay, so it didn't work. It didn't work anyways. It's my, let me see this thing here. These calculators are, you can't even see it down there. It's so small. How do I bring that picture up? I would like this picture to be, oh, can I do this? Ah, I think I just left it, didn't I? Oh, they're there. Show me in front of what? What kind of, I don't want to mess because I'm afraid I won't be able to do anything here. If I do something here, I'm afraid that I'll ruin it for the class. So I think on this calculator though, you could type this in directly and get it right. The first one is 24? Oh, sorry. I can't, I don't mean to laugh at your misery. Let's do one. 1A. All right, so you can do it on the calculator without even, you just type it in and it works. You didn't actually have to do anything except type it in. What you should do now, the reason why your calculator could do it, I was hoping it would be able to do it, although I didn't know what it would do. Your calculator should be able to determine what is done first according to the order of operations. Go ahead. No, don't do that each time. Leave it as one long string. Yeah, you don't, although I think, let me see. Let me come back to this. What would be the most inane way to do this? So we would do 4, and I don't say most inane, but you might go 4 times 7 equals plus 6 divided by what? 2 equals minus 7 equals. I can't get a wrong answer. I have no idea. Tell me what you're typing. 4 times 7, that would be equals on this one. There's 28. Your calculator show you 28 plus 6. No, that's a mistake. Yeah, listen. Each time you hit enter, you're entering parentheses in the problem. Did you know that? Yeah. When you hit enter after the 6, they're gonna take 2 and divide it by whatever was in there before. Don't hit enter, just type the thing in and then hit equals when it's all done. Try again. Don't hit enter, ever, until you type 7. Try it again. All right. This is why you are supposed to be in charge of computers and not them in charge of you. Did you know that all the time in a hospital setting, doctor's orders are mistaken? Pharmacy gets it wrong, then they get it wrong when they send it up to the nurse. And when that person dies or something horrible happens to him, he sues everybody in sight. That includes the person who's mopping the floor. What they're really trying to do is look for somebody with money. They do these things. The point I'm making is that the reason they pay doctors so much, they pay pharmacists so much, and they pay so much, is every single one of these people is responsible for determining when a machine has made a mistake. All of these people are in charge of that. Maybe they wouldn't know if they, well, I don't even. Anyways, this is why you need to be in charge of your calculator. What should you be doing first on this thing? What should be the steps? You want to do, what are the highest order of operations that are shown right now?
Division.
Subtraction or lower levels. So we can do the 4 times 7 first. And in fact, you can do the 6 divided by 2 at the same time because they are separated by a lower order of operation. But you absolutely have to do those first. And now, since addition and subtraction are of equal magnitude or equal importance, you can just go from left to right. So I get 30 minus 7. Yeah, yeah, right, well, there it was, the next one. Yeah, this one was not a good one. I'll show you. According to the order of operations, what is the first thing you should do on this one? All right, inside the parentheses, you can't really do 1 divided by 3. The only thing you could have done in there would be to have simplified. So parentheses are out. What's next? The exponent. Do you know what 1/3 to the second power is equal to? 1/9. 5/8 divided by. Now you have to handle that division before the addition. How do you work the division part of it? What do you do next? Flip it. So it's now 5/8 times 9/1. I still haven't handled that one part yet. Now I'm going to multiply. Multiply fractions, you just multiply the numerators together and the denominators together.
So you don't do the cross multiply thing?
Nope, only when there's an equal sign between there. So here we're going to get 45/8, which is probably annoying since it's not the denominator you want. So now you have 2 fractions with different denominators. What do you do now? That would be 72 would work. So I can rewrite everything over 72. So I have 45. Left, I'm sort of unfinished. What goes after that dot on the first one?
Look what I had before. That 45 was over 8 before. Now it's over 72. So how much did I multiply by? Times 8 is 64. Right? 72, where you got the whole idea. You multiply by 9, so I can change this into a 9. Any guess as to what you multiply this one by? Try again. 9 times what gives you 78? Now, look here. In a way, there is a cross multiplication. See this? So in a way, there is. Now, let me do those multiplications. 45 times 9, I believe, is 405. Five times 8 is 40. I can now add them together. Now, the only question to me is, does anything go into it even? Can you simplify? And if you try, this breaks down into 8 and 9. 8 doesn't go into 445, neither 9 nor 3 go into 445, so this is kind of what you're stuck with.
What was the, oh, you, oh, no, that's not the exact answer though, is it? Let me see, 445, hold on. Well, why not?
Your calculator may say it ends in a 6. Those, they shouldn't, what did you say the answer was? No, decimal. Six. That's what. Let me think about it. Okay, your calculator. So your calculator doesn't do that. But your calculator doesn't think that way. It's a program set in there and it's so many digits and that's it. Oh, this one, I forgot. Which of this should you do first? Right, you should not distribute. No, you're only going to distribute. The problem with this is you have to do exponents before you multiply. Distributing is multiplying. Exponents first before you multiply. So doing distributive is violating that. But even more so, you shouldn't do the distributive because you need to do the parentheses first. Those are the highest order of operations. You have to do the parentheses first. You can't do anything else. So we have 8 minus 2 is 6. 7. It's 2 times 6 to the second power. It's 2 to the. So what I can notice how I put the dot in there So I'm very clear to myself on what I'm going to do next. What's going to be the next step? That's going to be 36. So 97 minus 2 is 36. So do the 2 cubed. Next step is the multiplication. 72. 97 minus 72 is 25.
Now incidentally, if this square had not been up there, you could have distributed. That would have been fine. What's next? Oh, this one, this was, I don't know. I don't remember how good this one was. Let me go ahead and do space over here. Of course, all of these are simply to test your capabilities with the order of operations. Which part of this should you do at the very first step? The parentheses inside of the bracket. So the first thing that you should do in this problem is 12 minus 9. That's where you get the 3. I hate those X's, but I copied it from the book.
So this turns to 42 divided by, I'm going to leave everything alone except for the parentheses that I did. What would be the next thing you would do? Multiplication. You still got to work the brackets. So I'm not done with the brackets. Inside of the brackets, I've got to do the 2 times 3. So that'll give you 6. So you get 42 divided by 1 plus 6. The 1 plus 6, of course, is 7. Now, also, when I'm done with the brackets, this allows me to move on to the next thing. And so finding 42 divided by 7, this is something that everybody should know from elementary school. That's 6. It wasn't the worst one, for sure. Yeah, people did all right on that one. Hey, did I take care? Is that the first whole? That is the first page, isn't it? Okay. Other questions? Well, the answers are in Blackboard. If you don't get your questions answered today, you can at least go to there. Anything? We've only got 4 minutes before break. So I'm going to do one even though I didn't get asked. I want to do I. Looking at all these problems over here, I'm choosing I. There must be some reason why, and I will show you why. And then when we come back from break, I will start with new material. Okay. This one here, in order, when you do the distributive property, perfect opportunity to do it, because the reason why you would do a distributive property in the first place would be if the items inside of the parentheses were not all numbers, like this case. I can't combine the 1 and the X, so I don't have any choice but to use the distributive property. So I have 2 minus 3 plus 3x equals 3x plus 1. I'll pause there for a minute. If you understand what I got in that step, you understand how I got what I got.
So you combine the two minus signs, which turn them into a plus.
Negative 3 times 1 is negative 3. Negative 3 times negative x is positive 3. Question 2 is just hanging around. All I did was combine the 2 and the negative 3 on the left. Now, what would you do next? There's at least two different things you can do next. I would subtract 3x from both sides, because I always try to move my x's to the side I want them at the beginning. But this is a little bit different because, do you see what happens here? They go away everywhere. What are you supposed to do? Say when you get an answer like that, what are you supposed to know? It's indicative of something. What is that? There's no solution. Because negative 1 does not equal 1, correct? You did a series, each of these steps that we did is what they call a series of logical steps. And we started from the beginning using logical steps, we get to this fallacy. Since all of our steps were presumed to be correct from start to finish, what must be wrong? Problem. So this means there's no solution. There was 2 types of these. There was another type of problem where it may have come out that you got 1 equals 1 in the end. What happens if you got an equation at the end where it was actually true? Or all real numbers. So remember those, they're degenerate cases that have to be memorized or at least reasoned out when you come across them. All right, when you come back from break, I need you to take out your graph paper and your rulers because we're going to do some graphing. Hey, I was going to say 10 minutes. 10 minutes and we'll be back. I want to change. I do want to change the view, I think. Your name Caronsel?
Yes.
You can make up your test one when you take the final. or March. Not muted, am I? By the active speaker now. Oh, I see.
and sort of combine 4-1 and 4-2 together, but let me first draw a picture and tell me if you remember. I put some graph paper here on the table. You're gonna need some. You want to graph not by freehand, but with some sort of a flat edge. I will, when I have you do this, I will require a degree of precision. I mean, straight lines, all that kind of stuff. So with that in mind, let me draw up a picture and see. For most people, you have certainly had some sort of graphing in your life of some sort. Maybe not this kind. Have you guys ever seen anything like this before? Probably known as just a graph. It goes by various names. Some people call it a Cartesian coordinate system. Some people just call it plain old graph. Whatever it is you want to call it, I don't care. So long as you know what to do when you see one of these things. So first thing I want to do is warm us up to sort of remind. Well, I'm going to write the words plot. Now, unfortunately, for the people watching at home, they might use their lined graph paper. Same lesson in school. When I say plot the point, I'm going to write something down and then you tell me where its location is. So what I'm going to do is something like this. Inside of parentheses, we put two numbers separated by a comma. When we graph things, we use the format for our points like this, x comma y. That means the x coordinate is first, the number involving x is first, and the number involving y is second. In fact, you can see, if you look at this horizontal line here on the graph, it ends with x. If you look at the horizontal line that has an x on it, that's similar to a number line. In fact, that is a number line. But do you see that the x runs horizontally from left to right? And do you see that the line where it has a y goes up and down? It's vertical. So the x is the horizontal, y is the vertical. When I give you the point, I call the point 2 comma 5, I'm telling you that x is equal to 2 and that y is equal to 5. The easiest way to do it on this graph is to start at the center of the graph, count your way to the end spot. So imagine you putting your point pencil tip on the center of the graph. I said you go and plot the point 2, 5. So what you'll do is from the center of the graph, you'll go to the right 2 places, because that is where x would equal 2. And then you move up 5 places, 1, 2, 3, 4, 5. And then at where that location is, you put a dot. And that's the point 2, 5. Do you guys understand what I did? If you've ever played the game Battleship, you'll know how this works. All right, so let me give you one. So the way I graph, my lines are all one marking. So that 2, you'll notice there's 2 marks over it. I didn't label this graph because I'm just going to use the marks naturally. What if I were to instead give you the following? -3, comma 4. Tell me if you started with your pointer on the center of this graph, placed where the x and the y lines intersect. Tell me how I would get to -3, comma 4. So pretend you're at the center. Tell me which way I would go to -3. How many places? Places to the left. Make a marking. Then where do I go after I'm at that spot? Up 4 places, 2, 3, 4. And I'll put a dot right here. You can even go a little further if you wanted to, like you can tell everybody, oh, this point here is 2.5. You don't have to, it's pretty obvious from where I made my dot though. If you want to, you can tell everybody this is -3. I'll do this because it will be beneficial when people look back on this later on. All right, what about this one then? -4, that's a word. -3. Let me change my coordinate to them. Once again, I'm going to start at the center. Graph, I'll put my finger right on the center. Tell me how to get to -4, -3.
4 spaces and then
One.
down.
4 places to the left. It's -4 and then down 3. Okay, how about the next one? Let's try this one. How about 6, -5? So imagine you're starting at the center of this graph and you want to get to 6, -5. How would you do it? So you have to that center, where do you go? To the right. 6 to the right. But that's the 2. And then down 5 units. So I haven't labeled the last couple of them. Hopefully you do that as you don't. Then a couple of odd ones. How about something like this? 3, 0. So imagine I'm at the center again. How do I get to 3, 0? To the right, yes. Over is not a good enough word. Because over is not precision. So if I say go over 3, that's not good enough, but you said right. Okay. Which is what I need. Can you imagine, like, you're downtown, you don't know where you're at. I've been there plenty of times, trust me. And the guy goes, yeah, you go over to there. That's what precision is, what I'm trying to get you to be in this whole thing. Everything's got to be precise. So starting back again, if I start at 0, as you said, go to the right 3 places, and I'll just put a dot here and stay there. You're not going to go up or down any because of the 0. Similarly, if I were to give you 0, 3, where would that be at? Just go up 3 units to get to that one. How about this one? Do I have some space? There's a very special point, the one I'm starting at. Goes by the name 0, 0. That's the very center spot. There is a mathematical name given to that center spot instead of 0, 0. You know what it's called? The center's good, actually. I'm happy with it. The center is very good. But that's not the word they choose.
It's probably the eye.
Now I'm figuring out about it. No, it starts with another.
The origin.
The origin. You guys heard that word, the origin? 0, 0 is called the origin. If you want to call it the center, I'm fine with it. I have no problem. So that's how you get all of these. You have to be aware of wherever you're at on here. Left and right, that's the realm of X's. Up and down is the realm of Y. So between the two of them, they can get you anywhere on the board. Now, what we're going to do is we're going to be interested in formulas. So I may do something like this as an example. Plot. Plot instead of draw. Plot. And the equation. So what I've done here is now I'm giving you a formula that involves this. So try to turn that into this. So what we typically do is the following. Make up a chart. We'll learn better ways of graphing than what I'm doing today. This is very instructive. Get started. Now, what I'm going to do is I'm going to start plugging in different values for x. I'm allowed to pick whatever I want. What's the easiest number you can ever pick? Two easy, I'll do one, but you can. Which number is easier than one? Yes. If I replace x with 0, can you tell me what y equals? So look, y equals 2 times 0 minus 3. Tell me what that equals. 7. -3. Now let me draw a graph and put that point on it. Notice for off to the side here, this side work, I don't care about how messy I am. I have to be a certain level of, you have to be able to read what I do, but when it comes to the graph here, you'll notice I'm very serious about it. And I'll try to be extremely precise when I do it. Once again, which of these lines, the horizontal line is what name? And the vertical line is y. All right, so what I have here is the point 0, -3. Tell me how to get there from the center. Down 3 units, 1, 2, 3, and put a dot. Since the x is a 0, you don't go left or right. Now we can try your easiest version of a number, which is 1. That means y is going to equal 2 times 1 minus 3. Can you tell me what that's going to equal? -1. So I have a formula for y. That's what I have. Tell me how to get there on the graph. If I'm at the center, how do I get to 1, -1? 1 to the right and then 1 down. I'm going to pick one more one. Give me a number. I don't care anything. What for x? Well, if you pick x equals, I should be clear. If you choose something like x equals 100, that's not going to work for us. So, well, it's the x equals 5. I would have done -1, but y equals 2 times 5 minus 3. Can you tell me the y value? 7. And so 5, 7, how do I get there? Is it right? 5 on what? Up 7. Up 7. 1. Now look at the dots. Do they appear to line up in a line? We're not drawing a line just yet. We will, but not just yet. We're just trying to get a hang of this. How can I tell? Take your flat edge, your ruler, or whatever it is you have. Start at this one. Connect to that one and see if do they line up? They do, don't they? This is how you can check to see if you did it right. You understand? I wouldn't have picked 5 because that's way out there. I would have picked something closer to where it would have been more obvious that they were on a line. You know what I'm saying? Oh yeah, look, graphs are everywhere in business. This is nothing compared to what you'll probably be asked to produce for your bosses unless you are the boss, and then you'll ask them to produce the same things for you. All right, so that's the game. I'm going to give you a formula. From that formula, see if you can graph 3 points and they have to line up. So let's look this way. Graph and the equation will be y equals -2x plus 3.
Does everybody have a ruler with them? I got these like things I've picked up from here and there that have flat edges. Anybody want any? Get them to put a little ruler in the student handbook. You just pull out, you know. Do you want the flat edge? Your calculator is not a reliable flat edge, by the way. Whatever you do, don't write over your graphs. Go to a new graph every time. You might need to use lots of graph paper for that purpose. But I've seen some students try to draw the next graph on top of the old one. That's just crazy. Let me see something here. Anybody care to give me any values for X and Y that they decided to use? What's the easiest value of X always? 0. If you used X equals 0, what did you get for your Y? Three. Somebody give me some other numbers for X that you used. For X, what did you get for Y? I don't think that's right. Y was equal to -2 times 1 plus 3. So -2 times 1 is how much? -1. Sorry, -2. Sorry, -2 plus 3 is how much? Now give me another value of X to try. I'm never ready for yours, but all right. When you have X equals -3, what do you get for Y?
All right, let's go ahead and put those numbers in. So 0, 3. 0 means I'll stay in the middle and I'll go up 3. So right there is the 0, 3. 1, 1. Finally, -3, comma 9. I'll see if I have enough space on this graph for it. So I'm going to go 3 to the left. Put up 9. Now, based on it, can you tell if they're lined up or not? Use a ruler if you like that. I'm not certain. They do look lined up, but I don't feel certain until I throw a ruler down on it to let me know. So let me throw a ruler down on it. What I'll do is I'll grab the last point and I'll try to connect it to the first point. And everything should line up in between. Yep. What do you think? Do they line up? Sure do. So that's how you can check yourself. You need 3 of these. Let's try another one. I'm going to change it up a little bit for you. Don't be afraid to use a lot of this. I would recommend no more than 2 on a side of paper, so you can probably only get 4 graphs before you're done. Anybody care to volunteer some X and Y points for me? X is 0, Y was 4? Yes. Okay. Any others? 500? You will get the same answer. 500. Anybody else? I mean, you can go on all day. This other column's not changing, is it? So when you graph the points, what did it look like? Which way did it look like they were heading? Vertical. So 0, 4, let me go. 0, 4, going 1, 2, 3, 4. 4 is going up. There's 0, 4. 5-4 is off to the right 5 units. Okay, and then we had 1-4, that was just to the right 1, and we had -1. I don't think I need a ruler to tell me those line up. What's that? An aesthetic tree, yeah. There are certain places where that would be a great graph. This, if I were to take a line and try to connect these points, what kind of a line would you describe this as? A horizontal line. Horizontal, you remember, because of the horizon? That's what people does. Vertical, they don't have such a thing. So I could have given you this problem instead. Pause there. Do you agree that what I wrote right here is like that? Is that why? The only thing is, if I had given you this one first, you wouldn't have known where to plug the X's into. But if I had a 0x there, suddenly you know now where to put them. So what we're gonna end up doing is these kind of things are horizontal. And if y equals turns out to be horizontal in nature, this here was horizontal. If I had chosen instead to give you this version of it, what do you think it would be? X and Y. This means that y stays that number no matter what x is. It stays the same height. X equals 4 says that that x value stays the same no matter what y is. Down, but x stays the same. So when you graph that, I don't want to draw a graph, but this would be a vertical line. And I could play the same game. I could have said x equals like 0y plus 4, and I could have had the same thing happen. Now I've done the little trick to you here. This equation is not the same as the previous equations. You notice that x and y are both on the same sides now, aren't they? That changes things up, but you still can do the exact same thing you did before. Anyone care to give me any numbers that they tried up here? Zero X. 0, 4. How would I get there?
Start in the center. Spaces.
Got my 0, 4. Anybody else got numbers for me to put in there? What? I need at least 2 more.
3. X is 3. Y is 2.
X was 3 and Y was 2. How do I get there then? We start at the center again.
So right 3.
1, 2, 3. Okay.
Move up 2 spaces.
And then I need 1 more pair of points. House of words. What if I'm going to introduce? But we never did one on this side, did we? Did one on that side, did we? Did I? Now, what if you let y be equal to 0? And just because all the rest of them I did with x, I never said you had to do x, did I? That's probably why people hate math people so much. It's all stuff like that. But it's 0 for y now. If you let 0 equal y, can you tell me what the x value would be? 6, right? If you cover it up, if you let 0 be for y, you would have an equation like 2x equals 12, which tells you that x would equal 6. Do those dots look like they line up? They sure do, don't they? So I can see that they line up. I'm not even going to bother putting the line up to them. They line up. There was an interesting thing here, though. I inserted myself into the problem. See what I inserted that most other people would. What you did not. I put a 0 number where y does. That's the easiest number you can plug in, right? 0. Here, you can plug it in for x and you can plug it in for y. So that gives you 2 points right off the bat. The only reason I didn't do it before was because y was equal to x on one side. X is y on one side. So every time you fed it an x, the y was automatic. But in this case, it's not the same. If I give you an x, you got to work for your y. If I give you a y, you got to work for your x. You're stuck. You don't have it as simple as it was on the previous problems. So, oh, by the way, each of these has a name. When you do draw the line, this guy right here is called the intercept. Draw the line, that's where the line will cut through that the y. Oh, did I mention that's called the y-axis? Did I say that name? I said it accidentally, but I never. The vertical line is called y. It's called the y-axis. But the place where it crosses the y-axis is called the y-intercept. So using every ounce of capability that you have, logic and otherwise, tell me what they call that one. It's intercept. Yeah, it's not. It won't be draw lines for this. I want to get the book does this, so I want to. The y-intercept or the x-intercept is where it crosses the. Furthermore, can you tell me what angle the x and y axis cross each other at? I know we don't do geometry here. Perpendicular to each other. Just like battleship. All right, let me give you one now, all on your own, like this, and try to graph
3 points on it. So the same game as all the other ones.
So I'll start the table off like this. When I started by letting x equal 0, could you tell me what y was equal to? Then when I changed and allowed y to equal 0, could you tell me what x is equal to? Negative 4x, y is 0, so I have negative 4x equals 8. When I left y equals 0, look at the equation. Y is 0, it drops out of the equation. So when you solve this, you got to divide this equation by negative 4 to get the x value. Let me draw these two, and I'm going to connect them with a line.
I may click them after I do this. Did you guys ever hear the phrase, oh, maybe you heard this, what's the shortest distance between 2 points? Some of the sayings that were popular when I was a kid don't seem to be popular now. You never heard the phrase, the shortest distance between 2 points is a straight line? That makes sense though, doesn't it? Obviously, a curve is not the shortest way to get from one point to another. But in more precisely, if you have 2 different points, you don't need the third point. The only reason we were doing a third point was to make sure it lined up. It was a check. You only need 2 points to draw a line. So in this one here, if I draw my 2 points, 0, 8, all I have to do from the center is go straight up 8 units. There's my 0, 8, and to get to negative 2, 0, I'll go to the left 2 places and I'll put a dot there. Now to draw a line to connect them, you don't need any more than 2 points. Because I'll have the line already defined, well, not that. This one here. It's much harder for me to draw a line than it is for you. And you can actually draw your line just with the 2 points. You don't need 3 of them. The only reason why we had a third one was to make sure that we were doing it correctly. Now, with that said, does anybody have a third pair of numbers that I can put up there. Did you try anything besides zeros for X and Y? Would you say X was 1 and Y was 12? Yeah, sure. Except it's going to go off the chart now. That's what, let's see, yes, it will. It'll even go, actually, we can check, let's see. Say when X was 1, Y was 12. So that's Y minus, right here. Right, yeah, you can just add the 4 and you'll get Y equals 12. So 12, I'll go to the right one and then I'll go up 12. Does that look like it's on the same line? Or is it slightly askew? Let's take a look and see. I can grab my line back and I can stretch it again. I did not mean to do what it had me do here. I want to grab the end of it. What do you think? Do they line up? I should make an indication to you. If you do a big fat dot, how do I want to say here? Let me have, I think, it's not going to change color on me, is it? Yes, it is. Look at this thing. Big fat dot like that. Do you see how it's not quite on the corner and everything like that? Be careful of fat dots because they can throw your graph off. So the game plan then for us is I'm going to ask you, instead of 3 points, I'm just going to say graph the thing. That means I'll expect you to draw a line. And all you'll have to do is find these things. What are these called again? Intercepts. The X and Y intercepts. If you can graph those, then you're able to get it. The only reason we needed the third point was to make sure that we were doing it correctly. Now, let me finish with one last example here. This is, we're technically in 4-2. I think that's the right size, but I don't know. That looks awful thick. There we are. So what you're going to see when you hit the homework for 4.2 is things like this. They'll say graph. I don't know, let's say negative. I usually use 5x 3y 15 by binding intercepts. So when I say to do that by binding the intercepts, can you tell me what are the things you're going to chart? Like get on the other ones, but can you tell me how you're going to set up the chart? Put on this chart yourself. So I'll put a 0 for X, 0 for Y. How's it? When X is 0, could you tell me what Y equals? Perhaps one of the easiest ways to do it, if X is equal to 0, you can just take your hand and physically cover it up. Can you solve that equation of range for Y? It's pretty easy. Now, if I'm going to let them Y equals 0, cover it up and tell me what you get for the X value. Not 3. Negative 3. So all I need are 2 points. 2 points determine a line. 2 different And so I'll go ahead, now that I have the intercepts, I can now sketch the graph of my line. And this is where the straight edge will come in. Gotta make sure these are on. 0, 5. I want about that. All right, I'm gonna start at the origin. Tell me how to get to 0, 5. I'm gonna use this to do the plotting. I'm at the origin right now. See me? Go up what? And put a dot here. There's my dot. So I like that nice little bitty dot. Can you guys see it? You can't see my dot? It's there, I made it pink. You see it? All right. Now, -3, 0. I'm starting at the origin. How do I get there? -3, 0. Tell me how to get. Go left 3 units, 2, 3, and I'll put a dot here. So you can barely see them, but there they are. And then what am I going to do with those two things? Connect them with a straight line. That's right. And that's it. It's the smartest idea is like you would just connect the 2 points, and then any point in between will line up. For me, it's a little bit more complicated. This does not act very easily to me. And there you go. So that's where it will end in the homework is you'll be plotting the intercepts and graphing the line that connects them. Make sure you use a straight edge. I will require you to use a straight edge on the test. If, for those of you that are watching from home, if you want your tests back, just send me an email and I'll scan them into you. There's no classes next week. Spring break is next week. So enjoy that. Personally, if it were me, I would practice graphing the whole time, but that's what we did when I went to school. A what axis?
Give me a Z maybe.
A Z. Well, there's 3-dimensional graphing. You won't have to supply your own graphing. That's all you put it in. Yeah.
The link that you send out for the online class, do you send it to?
No. Go through Blackboard. You see where it says Alex in Blackboard?
Yes, I could.
Just click on that. Do you have your laptop with you?
No, I don't have a lot. What's at home?
Okay. Did you see? I made a video too. Did you watch that video or told how to get on?
No, because when I go on Alex, it just shows.
No. Forget Alex. Go into Blackboard.
Okay.
In Blackboard, there's a button called Alex.
I'll put it up on my phone.
Stop sharing. Stop recording.